Welcome to the DX Today podcast, your daily deep dive into the AI ecosystem. I'm Chris, and joining me as always is Laura.
Chris, I'm genuinely excited about this one because today we are stepping away from the usual frontier model drumbeat and walking straight on to an actual factory floor.
That is exactly where I wanted to take this conversation. The story today is humanoid robotics, but not the slick demo reel version that everybody shares on social media.
And the short version, before we dig in, is that humanoids are finally doing real work at real companies. But the gap between the investor pitch decks and the reality on the line is still enormous.
Let me set the landscape for listeners. You have Figure AI running pilots at BMW, Agility Robotics running Digit inside Amazon fulfillment centers, and Boston Dynamics lining up tens of thousands of Atlas units at Hyundai.
And then there is Tesla Optimus, which sits in a very different category because Tesla is manufacturing them. But Elon Musk himself admitted on the fourth quarter 2025 earnings call that no Optimus robots are actually doing useful work yet.
That quote is the one that stuck with me the most this week. He said the Gen 3 units coming off the Fremont line right now are for learning and data collection only, not for productive labor, which is a remarkably candid thing to say when your stock is partly valued on the Optimus story.
Which is a surprisingly honest admission from Musk, and I want to come back to why that honesty matters for how investors are now quietly repricing the humanoid robotics sector as a whole right now.
Before we get to the money side, let us start with what is genuinely working today: Agility Robotics. Digit has been inside Amazon warehouses for about a year now, doing tote handling in very specific zones.
Amazon has been pretty careful about what they claim publicly, but the data they have released shows two things very clearly. Ergonomic injuries in those tote transfer zones are down meaningfully, and Digit is still slower per pick than a trained human associate on the same shift.
So the value proposition is not speed. It is about taking humans out of the repetitive bending and lifting motions that cause injuries. That is a very different pitch than what Silicon Valley has been selling investors publicly.
And honestly, that is a much more durable value proposition. Because if you are competing with a human on pure speed alone, you will lose on cost of ownership every time in the near term right now.
Figure AI is the one getting the most media attention right now because of the BMW deployment, which is at the Spartanburg, South Carolina facility. What are they actually doing inside that plant today?
Material handling and parts transfer, which sounds mundane, but those are the exact tasks where humanoids have a real edge over traditional fixed automation because the stations keep changing and retooling costs serious money every time.
Meaning a humanoid that can walk to a new station and just start working is cheaper than re-engineering a conveyor belt every time the vehicle platform changes. That is the core economic argument behind the entire category. And it is actually a pretty strong one if the reliability numbers keep improving.
Exactly. And Figure just announced that Figure 03 is rolling into more pilot sites, including what they are calling domestic trials, which I suspect is their cautious way of hinting at home deployments eventually over time.
I want to talk about home deployments in just a minute, because that is where the marketing and the actual reality diverge the most dramatically. But first, Boston Dynamics and the enormous Hyundai deal.
This one is, I think, the most interesting strategic play in the entire category. Because Hyundai actually owns Boston Dynamics and is vertically integrating from chipset to vehicle to humanoid in a way no other automaker is attempting right now.
The number that got quoted in the register back in January was tens of thousands of Atlas units deployed across Hyundai Motor Group manufacturing facilities over the next several years of their roadmap.
Tens of thousands is a staggering number when you remember that the entire installed base of humanoid robots across every vendor worldwide is probably still under 10,000 units deployed in actual production environments.
So Hyundai alone could more than double the global installed base on its own roadmap, which is an almost unbelievable claim until you remember the scale at which automakers think. That changes the competitive landscape dramatically if they actually hit those deployment numbers on the schedule they have publicly committed to.
The word "if" is doing an enormous amount of work in that sentence, Chris, because we have seen ambitious humanoid deployment numbers promised before, and very few of them have ever actually landed on the original schedule.
Fair point and well taken. Let us talk about Tesla Optimus for a minute, because it is the real outlier in this whole discussion. Tesla is treating Optimus more like a software product than a robotics product.
That framing is really important to understand. Musk has been very clear that the goal is not to sell Optimus as a piece of hardware first. It is to train the neural network on millions of hours of embodied data,
which is why they are deploying internally at Fremont, rather than selling units to third parties yet. Every Optimus on the Fremont floor is essentially a data collection node wearing a humanoid form factor right now.
And that is either brilliant or a multi-billion-dollar distraction, depending on how you feel about Tesla's ability to execute on software deliverables. We have seen both outcomes from that company in the past several years.
Let me zoom out for a second and ask the big question that everybody is thinking about. Why now? Humanoids have been a research project for 20 years. What changed recently that made real deployment possible?
Two things changed, and they are both tightly related to each other. The first is vision language action models, which let one neural network generalize a skill across many tasks without per-task reprogramming by an engineer.
So instead of writing a careful script for the robot to pick up a bin, you showed a video of a human picking up a bin and it figures out the motion policy itself from scratch.
Exactly. And the second major change is that the imitation learning stack has finally matured enough that a few hundred hours of teleoperation data is enough to teach a new task at acceptable reliability levels.
That second one is the unlock I do not think enough people appreciate yet. You used to need thousands of engineering hours per task. Now, you just need a few skilled operators wearing VR headsets for a couple weeks.
And that completely collapses the economics because suddenly the cost of onboarding a humanoid to a new task is measured in days, not quarters, which changes the deployment math entirely for most manufacturing customers.
Let me push back a little bit here, though. The reliability numbers I have personally seen are still well below what you would accept from a traditional industrial robot on a genuinely high-speed assembly line.
That is completely true, and I want to be really honest about it on the show today. Humanoids in 2026 are doing tasks that traditional robots cleared a decade ago, at cycle times that are frankly embarrassing when you compare them directly to a well-tuned industrial arm on the same line.
So why deploy them at all? If a fixed arm is faster and more reliable and much cheaper, what is the actual strategic justification for a humanoid in the first place on any factory floor?
The answer is flexibility above everything else. A humanoid can move between stations, handle unexpected exceptions, and fit into workspaces originally designed for humans, which means you do not have to re-engineer the entire facility around it.
So the real pitch is not replace the industrial robot, it is replace the human in tasks where you cannot justify a bespoke automation cell, but you still really want to remove the person from that station.
That is exactly right, Chris, and it maps to a very specific category of work which industry people call low-volume, high-mix manufacturing, along with logistics tasks that vary meaningfully from hour to hour.
Now let me ask about price, because I keep seeing wildly different numbers depending on who is doing the talking and what they're trying to sell. What does a humanoid actually cost today in practice?
The hardware itself is somewhere between $30,000 and $150,000, depending on vendor and configuration, but the real story is total cost of ownership, including remote operators and constant firmware maintenance.
That remote operator cost is the piece that does not get talked about nearly enough in the public conversation around the humanoid sector. Every deployed humanoid today has a human somewhere in a control room who can take over when the onboard AI gets confused or fails.
And that human might be watching 4 or 5 robots at once in a control room, but they still need to exist. And that cost shows up on the operating line even if it is never on the original purchase order.
So when you hear a vendor quote a payback period of 18 months, you should immediately ask whether that calculation actually includes the teleoperations staff required to keep the fleet running. In most cases I have seen, it does not.
And that is exactly why the honest deployments we are seeing today are focused on injury reduction and flexibility, rather than raw labor cost arbitrage, because the raw cost math just does not work yet at scale.
Let me ask about the home robot question, because that is what everyone in the comments section and on social media actually wants to know. Are we close to having a humanoid working in the kitchen?
My honest answer is no, and not for the reasons most people think. The AI is getting good enough fast, but the safety certification and liability framework for an autonomous robot in a home kitchen simply does not exist yet.
That is such an important point that gets missed constantly in every consumer-facing pitch. The factory floor is a controlled environment with trained staff and formal safety protocols. A home kitchen has a toddler and a dog and a wet floor and a rotating cast of unpredictable visitors.
And the consequences of a factory humanoid failure are usually a scratched part or a stopped production line. The consequences of a home humanoid failure are potentially a lawsuit that could end the entire company overnight.
So the domestic trials that Figure and others are hinting at are probably going to be very narrow in scope. Think folding laundry under careful supervision, not unsupervised cooking for the kids on a weeknight.
That is my read on it as well, and I think it is genuinely the right approach. You build trust in constrained environments first, you collect data on failure modes, and then you expand the operating envelope slowly over time.
Let me close with the investor angle, because the humanoid robotics sector has absorbed enormous amounts of capital in the last 18 months from pretty much every major venture firm. How should people actually think about returns?
I think the honest framing is that this is a 10 to 15 year investment horizon, not a 2 to 3 year horizon. The companies that survive will be the ones that treat this as a generational platform bet on physical AI.
Which means you should expect a lot of consolidation along the way, some spectacular public failures, and probably a couple of breakout winners who will look completely obvious in retrospect, but are absolutely not obvious today.
And I would watch the automotive manufacturers especially closely because they have the manufacturing expertise, the deployment sites, and the balance sheet capital to absorb losses in a way pure-play robotics startups simply cannot.
That is a great note to end on for today. The humanoid revolution is real, but it is going to look much more like a slow industrial rollout than a consumer technology explosion over the next few years.
And that is actually a more interesting story, in my opinion, because the companies winning this race will be the ones who can execute on the unglamorous logistical parts of industrial deployment at real scale, not the ones with the flashiest demo videos going viral on social media every other week.
Laura, thank you as always for a genuinely terrific conversation, and thanks to everyone listening for sticking with us on a deeper dive that really needed a full episode to cover responsibly from every angle, because the humanoid story is going to keep accelerating through the rest of this year. That's all for today's episode of the DX Today podcast. Thanks for listening, and we'll see you next time.